Very good morning to you guys. Today we are going to look at addressing modes. Addressing modes. Okay, so someone may ask, what is this all about? What are addressing modes? So here we are saying every location in memory has its own unique address. All right? Every location in memory has its own unique address. Okay? So we want to be able to retrieve any item currently in memory or be able to store any item at a specific location. That is the idea. So there are several ways for programs to refer to these addresses. These methods are called addressing modes. Because remember, we have some data that we need that is stored at a specific memory location. At times, we might need some data stored at a certain memory location. So in order for us to store and take back or retrieve that data, we need to have ways of actually doing that in computer. So these various ways are the ones that we call addressing modes. I'm sure I'm making sense. So memory addressing modes, let me define that. Memory addressing modes determine the method used, determine the method used by a running program to access its data or next instruction. To access its data or next instruction. Okay? So memory here includes the internal registers of the CPU as well as the external RAM. So the memory that we are talking about here is number one, we have internal registers. My registers, I'm sure in the previous tutorials, I explained what registers are. And number two, the external RAM. All right? These are the memory locations that we are talking about. Then there's also one thing that I want to discuss with you, something that is called an operand. An operand is the data it is the data to be fetched. So data ratikuda kustore kana kuretrieve from certain memory locations ndorinonzi operand. Okay, I have just defined an operand because we are going to use that word most frequently in addressing modes. So I can start writing the addressing modes in your syllabus. The first addressing mode here, which is number 1, is the direct addressing mode. Direct addressing mode. Okay. What is direct addressing mode? So in this mode, we are saying address of the operand is present in the instruction. What are we saying? We have the instruction. So instruction is opcode. Okay. User address A. Address A. Okay. And this one is the memory. Yeah, 1, 2, 3. Okay. So operand or the data inenge iri panapa. Operand now this is the operand. So this is what happens. All right. Like I told you, address of the operand is present in the instruction. This one is the instruction. So the address A, do address it is stored in instruction. The address A data. Okay. For example, e.g., we can say add R1, 4,000. Now, what this means is that 4,000 is the address of the operand. So, inobva yangonongedzera kumemory pane that address ndo panenge paine data redu. All right. We move to indirect addressing mode. Now, on indirect addressing mode, the address field of the instruction gives the address where the effective address is stored in memory. But you realize that this slows down the execution, as this includes multiple memory lookups to find the operand. So in this case, let me explain with the diagram. This is the instruction. Okay. So we have our opcode and we have address A. I can shoot to add A. Okay, and this is the memory. So this is memory. So address A is pointing here, of which here there is the pointer to the operand. You have a pointer to operand. So the pointer to operand, open up, chipointer pane operand pacho. So operand will be here. Okay. So as you can see, we have the address, which is pointing to a pointer. The address A in instruction is pointing to a pointer. That pointer is now pointing the operand or the actual data. So that's the reason why I've been saying it actually slows down execution, because there are so many memory lookups in this addressing mode, the indirect addressing mode. We now move to relative addressing mode. Relative addressing mode. Okay, so in relative addressing mode, the contents of the program counter is added to address part of the instruction to obtain the effective address. This is what happens with this one. Okay, so the effective address, the address where the operand is got by, you get it by, because the definition is saying the contents of the program counter is added to address part of the instruction. So the address part is this one, plus the contents of the program counter, PC. That's how we get to where the operand is located. Okay. From there, we move to immediate addressing mode. Number 3 with immediate addressing mode. Now, on immediate addressing mode, the operand is specified in the instruction itself. So in this case, apana need kuti pane address, address yoyo ndoiri kuzoti iratidza ku memory location kune operand. Operand yacho itori mu instruction itself. So in immediate addressing mode instruction is an operand field rather than the address field. Okay, so we are saying the instruction is like this. It's in opcode. So instead of writing the address here, panenge patorne the actual operand itself, or the actual data. Okay? For example, e.g., it will be like add 7. That opera. So this means that add 7 to the contents of the accumulator. 7 is the operand here, the actual data that we need. Apa apana wisukoma address, pakatres called the actual data per instruction. All right. Last but not least, we need to look at indexed addressing mode. Indexed addressing Okay, so on the indexed addressing mode, the address of the operand is obtained by adding the contents of the general register, called the index register, and a constant value. Okay? For example, it can say load R1, 100. So we are simply saying add contents on memory location 100 to the register R1, which is the index register. Okay? So this marks the end of our lecture today. Thank you very much, guys, for watching. I hope and trust that you have enjoyed this tutorial. If you have any questions, please don't hesitate to let me know at 0784 002 002. And also don't forget to subscribe and like on my YouTube channel. Goodbye.